Assalamualaikum. My name is Amin Asyraf bin Rahman, and today I would like to present my final year project 2 called Development of Dual Mode Controller for Electric Wheelchair. Here's are the outlines for today's presentation. Most of the contents can be found in final year project 2 report. The introduction in this project starts with the project overview. The development of dual mode controller for electric wheelchair is a project that provides an option of controls in an electric wheelchair. The main focus in this project is to develop a voice recognition system that responds to the voice command as an additional option of controls in an electric wheelchair. The actual final result of this project is to move the electric wheelchair using voice recognition and joystick controller with optimum accuracy and reliability. Next, in problem statement, most of the physically disabled person does not have the dexterity required to use manpower to move the wheelchair and must use the joystick controller on the armrest of the electric wheelchair. The problem arises as a drawback for quadriplegics who is unable to move their parts of arms and legs. If the patient lost uses of the arms or fingers, they cannot use the joystick. Meanwhile, if the patient lost uses of voice, they cannot use the voice control system featured in the wheelchair. In this slide, there are three objectives required to achieve for this project. The objectives are to develop the model of electric wheelchair, to integrate the voice recognition module with joystick controller, and to analyze the response of electric wheelchair based on the voice command and joystick controller. The scope of the project involves the integration of existing voice control technology to the current design of joystick control electric wheelchair. This proof of concept project is developed to respond to voice command that involve basic movement and trained in English language. In order to demonstrate the voice controller technology, a PVC frame are used to build the wheelchair with one-to-one scale. When a specific voice command is input to the voice control module, the motorized wheels attached to the wheelchair will move in certain degree and make specific directional movement. Next, I'm going to talk about the literature review for this project. This is the literature review for voice control electric wheelchair. From the voice control wheelchair, this project uses the same microcontroller as my project. It has relations with the integration between the voice recognition system and joystick controller. It also has an expected result that might give a clear glance of what is the result of my voice recognition test. Next, from voice controlled motorized wheelchair, this project uses the same microcontroller as my project but with an addition of GSM module. This literature review relates with the voice recognition system flowchart of my project. It also uses the same model for the voice recognition module. This is the literature review for other voice control system. From Arduino-based voice control robot, this project uses the same microcontroller as my project with different set of chips and one of the easiest projects that can relate with my electric wheelchair project. It has relation with the testing method of my project by saying forward and stop to test the voice recognition system. Next, from voice controlled home automation system for the elderly or disabled people, this project uses RF module and AVR microcontroller. This project has relations with the on-off testing and testing method including different types of environment and condition. The next slide will include the methodology for this project. This is the workflow for this project. It stretches from the beginning of FP1 to the end of FP2, which is from finding the least review and construct conceptual design until executing the assembly and testing of the project. This is the system architecture for the project. This is the flowchart of the voice recognition control. This is the flowchart of the joystick control. This is the project planning for FYP1. This is the project planning for FYP2. And next, I'm going to explain the wheelchair structure of this project. This is a side view of PVC wheelchair frame. Now, this is the front view of PVC wheelchair frame. And now is the top view of the PVC wheelchair frame. And then this is the final SolidWorks PVC wheelchair frame design. And then later on, this is the finished PVC wheelchair frame design. This is the voice recognition setup shown in step by step. The purpose of the setup is to import the recorded voice command into the voice recognition module. Result number in this table means the output voice of the recognition module. It was used later in the Arduino coding. Next, this is the project circuit construction using freezing. These are the pin configuration for the electric circuit. The program of this project was written in Arduino IDE and has two sets of coding, one for the voice recognition module and one for the joystick controller. Case function was used in this voice recognition coding, while if else was used in joystick controller coding. This is the hardware selection for this project. This is the software selection for this project. Based on all the selection, total cost of this project is 807 ringgit and 40 cent. Next, I'm going to talk about the result and discussion of this project. The device response test is for taking on the objective of this project. Uh, this is the testing condition, which is on and off. Between the voice recognition and joystick controller, the data shows that when the devices are on, they will respond accordingly to their commands, whereas when the devices are off, they will show no response. This is the recognition response test. It includes the manipulated variable of amplitude of the voice, distance of microphone from the mouth, and the environment. The test conducted is to find the number of correct response. Set by the previous table on the slide, normal voice and whispering has a difference of 20% of accuracy between them. The accuracy is decreased by half when talking to the microphone 5 inches away from the mouth, while the distance of 1 inch and 3 inches away detects the voice command given. 7 inches away from the mouth does not detect the voice command given at all. The voice recognition shows excellent performance in all environments. This shows that the devices can be used anywhere as long as it used correctly. Joystick controller response test is to see what response when leaning the joystick in multiple directions. When the joystick leans forward, backward, left and right position, the DC motors will activate. Now for the conclusion and recommendation. The data analysis shows that the voice recognition and joystick controller are integrated together by the on-off testing method. Hence, the objective to integrate each device was successful. The limitation in this project is when testing indicates that the voice recognition needed to use in an optimized situation, meaning that the mouse should be in close to the mic when talking in normal voice. For future works, implementing ultrasonic to this project is one of the obvious improvements that can be made. Lastly, for the references of this project, listed here are the four main references that can be found in the literature review. That's all from me. Thank you.